Hi, everybody. Hello and welcome to the January 12th, 2023, first of the new year, SIG KCP Edge meeting. And we have a good size agenda today. I'd like to get started. If you turn your attention, I'll share with you the screen that I'm looking at. Okay. So just to get started, any of the topics that you'd like to discuss, please enter them into the issue. The issue is tagged. It's number 65. If it's also in the chat for this WebEx. And just to get started, we have a contributor code of contact. And as contributors, maintainers in the CNCF community, and in the interest of fostering an open and welcoming community, we pledge to respect all people who contribute through reporting issues, posting feature requests, updating documentation, submitting pull requests or patches, and other activities. In other words, please just be nice to each other in this forum. So today we have a few things on the agenda. I'd like to get started. Mike, if you want to go first, or
Sure.
would you like? Yeah, go
Yeah,
ahead.
and I think the representation in the agenda is a little bit thin compared to the issues, but it's not a big deal. It's just there's a lot of little niggling issues around the checking that CI does about our logging. We use this tool called log check, and there's been a lot of issues around it. One of them is called out here, which is that the CI invokes a script that invokes log check twice. But without a way to differentiate the output. Now, for most of the output, it's implicitly differentiated because it has a file name in it, so you can tell what file it's talking about. But the error messages that says /././ has no packages. You can't tell which invocation it's coming from. So I did a PR to deal with that. More interesting is the checking itself. The main KCP repo is stuck on an old release of this, version 0.2.0. And I've gotten some bug fixes in. So for example, the first one was it was objecting to calling klog.init flags when doing checking for contextual logging. But init flags is a perfectly legitimate thing to call. It's not a violation of the principles of contextual logging. So we got a fix in for that. I also got a fix in for the error messages. So this tool is checking when you check for structural logging, it's checking that you see we're calling structural logging. The idea is the call to emit the log has a message and then a bunch of alternating key and value pairs. And in the Kubernetes community, they have a page where they've defined the expectations for those keys. And basically it says use lower camel case. And the way logcheck works is it has a regexp and that it matches the key against. And if it fails, it was giving an error message saying you shouldn't be using special characters. Well, that's not even a decent error message because if you say start with a capital letter, if you use initial capital case or whatever camel case, it'll fail. And the error message is completely inscrutable or misleading. Anyway, so I fixed the error message as well. So if we pick up 0.4.1 of that, we'll get the bug fixes. But the KCP people don't like picking up the checking for those keys because they like to violate the Kubernetes community rules. They like to put a dot in their keys. So I've opened an issue on the main KCP repo. Last I heard, Andy says, yeah, we like to put a dot in it. But I say, why are we diverging from the Kubernetes community? And I haven't seen a response since then. So I think that's where the real remaining issue is. The other thing is, we've done a lot of copying from the main KCP repo. Do we want to maintain consistency? So, for example, for this thing about the differentiating the output from the two calls to log check, do we want to try to propagate that back to the main KCP repo? So those are the things I have right now. Oh, so I just relay. So Andy's the thinking that I got from the main KCP people is when you have a controller manager that has multiple controllers, the thinking is each controller has keys that identify which controller it is. So the point of the dot is you name the key with controller name dot, variable local to the controller.
Okay.
I could argue that that's redundant since in general you have multiple keys in one line. And naming the controller in all of them is just redundant. Really, the point is the message should be identifying the controller. The log format has file name and it's got the message. That should be sufficient to identify the controller. Um, so, I think we could argue the point, but, the issue is, you know, there's discussion to be had or not, depending on our point of view for approach.
Okay. I know we have Joaquim's on the call. Oh, sorry. Go ahead, Paulo.
I just wanted a more clarification. So this seems to be more a problem of style, you can say, Mike, and because of that, maybe the validation rules are somehow different in KCP core versus what we
That's
like to have.
that's right. Right now the main thing is there's difference in style. They don't want to pick up the latest release of the checker because it checks a style they don't like.
Okay. Sorry, Andy, go ahead.
That's okay. Joaquim, I noticed you were on the call and your experience with KCP, of course. Any comments or information pass along?
No, about this topic about the keys, I have honestly no opinion. I guess everything can be, well, the proper route is to discuss that in the KCP issues, and I guess we will find a solution for everyone.
Okay. All right. Mike, anything else you want to bring up?
No, I agree. I think the main thing is to get some resolution in the broader KCP community. And as I said, I have an issue open to try to do that.
Okay. Thank you. All right. Any questions, comments for Mike? All right. So something that I wanted to speak to all of you about, I've been having, I initially at the beginning of the week broke the build and was able to get things back on track over time. I'm learning much the same as the rest of you. So for me, there was an understanding of what the vendor subdirectory was used for, for local libraries and packages. And having that present was causing issues whereby the code gen wouldn't generate or wouldn't find the package that needed for code generation to use in its path. So after removing that vendor directory, that seemed to free things up. Also, some changes in the code gen and the CRD generation scripts where they were referencing the KCP dev KCP repository instead of EdgeMC, and so I've made changes there. There was some ordering items that also were pointed out. Mike, thank you very much for going back and forth with me on those, and I've submitted those in the latest PR. We also had some changes in the make file. I've tried to closely mirror what it is that KCP has to the degree and extent that I've actually left in a couple of references to the KCP repo. Those have been removed as well. And so at this point, I think we're at the point where things are operational and they're not throwing any kind of issues inside of the CI workflow. The next step here, I think, is to actually test it with some API. And I think that that's already been brought up in one of the issues. Mike had commented and, push the envelope. Let's see if we can actually do something with some real API references. So I'm looking forward to that. So Mike, is there anything in the code generation aside from testing it out with real APIs in our EdgeMC repo? What other items are you looking to cover there that would help us satisfy and resolve this?
I haven't caught up with the latest changes overnight, but broadly speaking, I do have an API PR there, right? So we should be able to get that merged
Right.
with code generation, be able to proceed on the controller that I started writing, which right now doesn't actually do anything with our API, right? So the next step is to actually start getting code that works with our API, make sure it just runs.
Great. Perfect. Okay. Good. All right. I'll continue to work with you collaboratively as you see fit. Thank you for your guidance and feedback. I don't have anything else here to explain. Yeah, Paolo. You on mute?
So you piqued my curiosity about this vendor directory. Was this something generated by the scripts? Because I didn't see this in the KCP core repo. I don't know if it's something that we created or we inherited somehow from somewhere. So where was this vendor directory?
Yeah, I know. So this is my naivete. What I was looking at, and I'm just flipping over to source now. Let's see if I can see where I put it. Where is my source? There it is. So I'm just looking now. I thought, so what I had done is I was toying around with KCP a bit and, learning Go and how Go operates, how it compiles and how it does its generation. And what I found was, what I was doing with the KCP source is I actually did a Go mod vendor and that pulled a vendor directory.
Okay,
So-
so you probably created maybe not necessarily, voluntarily this directory, just using the Go commands.
Well, I
Right.
pointed Andy at some existing examples of code generation. I pointed him at Kubernetes, for example, which is, has been slow to move into modern Go practices. So I think they're still dragging around a vendor directory. So that's
Yeah.
confusing.
That threw me off. And so I was like, all right, so when I was trying to solve the code gen issues that we were seeing, what was happening is one of the code gens, there's a collector gen and that referenced a library in the Go mod, but because the vendor directory was there, it was pulled away and says, oh, I should use the local copy instead and couldn't find it. This was consistent in KCP too, because when I ran the Go mod vendor in KCP source, it did the same, it had the same behavior. So when I realized that was the problem, I deleted the vendor directory and it started to work again. So that's when I knew I had made a major mistake. So I learned.
Okay, thank you.
Thank you. And thank you, everybody, for being patient with me in learning in this space. Appreciate it. Okay.
But by the way, one question, I see that at least in the KCP core, I see that in the types, they also have some KubeBuilder annotation. So is that something also that we are supporting now with the code that we ported from the KCP core? Mike,
Let me refine that question. So we want to try building controllers without using controller runtime. We want to use the lower level facilities directly. So what I've asked Andy is, Andy volunteered to look into the problem that I've posed, which is we want code generation that doesn't build in unnecessary dependencies. Now, if we're using KubeBuilder to generate code, if that code does not build in a dependency on controller runtime, we can probably use it. If it builds in a dependency on controller runtime, we may have a problem there. But that's, as far as I know, TBD, based on investigation.
Yeah.
I don't believe that in the KCP core they have this dependency on controller runtime, but they are actually using KubeBuilder annotation in the APIs that they have, in the types, if you take a look.
Right.
To some
So
of them.
my question, another way of putting it then is this only helping the code generation without building in a runtime dependency on controller runtime? And if so, if it's actually improving the code generation, expanding its scope or making it more convenient or anything like that, then that's fine.
Yeah, because I believe there are many things that KubeBuilder does in terms of code generation. For example, creating the API schema and status subresource, other stuff that you can see from the annotation that I'm not sure it's actually covered if you're just using the plain client Go.
Exactly. Right. So the question is, if it just gives us benefits without undesired dependencies, then that's great.
Yeah, so I think we should also look into that because we may be losing functionality for the types, I mean, for the CRD generation and the stuff, if we just stick with the plain Go stuff, Go client stuff.
I mean, plain Kubernetes.
Yeah, client Go, the standard generator without KubeBuilder, generation.
I agree exactly, right? And that's what I've been trying to say. So that's part of the question that Andy volunteered to look into.
Yeah, so I'd like to see in the next step, right, is let's get the, the controller that you've got there, the skeleton of what you've got there, Mike, and then associate that with CR and an API, and then let's figure out, where the gaps are, where the gaps remain. If it helps, if it doesn't, we can adjust it accordingly. Okay. Any other questions about CI for now? I know that there's a generic question about CI not being opaque enough, or transparent enough. So I'm going to look into that offline, since the folks that I'd like to ask that question to are not on today. All right, let's move on to the next one. Mike, would you like to take the floor next to discuss summarization?
Okay, yeah, I hadn't gotten as far as I had hoped. So let's see, maybe I'll share where I'm at, and some of the questions that I'm struggling with. So let me try and share my screen again. Right. Okay. So, well, I have a lot of stuff, obscuring stuff. Okay. It's a little bigger. So I'm working on a revision. Let's see, oh yeah, right. So earlier I proposed something, and wrote up a Google Doc about it. And the idea was that there would be an API object called classifier that describes how to summarize the status from a particular kind of object, or from a particular object. And the idea is you would put an annotation on that object that points to the classifier that says how to summarize. And that would cause the edge system to produce summaries. So I produce a definition for classifier and a definition for summary, status summary. And the idea was basically that the classifier would describe how to extract a feature vector from each object at the edge, from its presumably its status, but could be any part of the object. Extract a feature vector, and the summary would then just be basically a histogram of those feature vectors. That's to say, a map from feature vector to count of edge objects that have that feature vector. And Constantine properly observed, I believe, that this was, if I recall, maybe, I'm not sure who it was, but I think it was maybe Constantine. This is really a small subset of what you can do in SQL with aggregation in SQL. The key concepts there are known by the keywords group by. In a select statement, you can group by, and that's basically describing the feature vector extraction. And then in the select statement, where you select this, that, and the other thing, they have more. What I proposed, my first proposal was basically equivalent to the count, count star, or just count. But they have other kinds of aggregation, right? Yeah, it was Constantine, because he was proposing other kinds of aggregation too. You can sum, you can average, you can find the max, you can find the min. Those are the ones that are built into SQL. And I think that in Edge, we should also allow user-specified aggregation functions. I know in transparent multi-cluster, or in support of it, that there's been some work on allowing developers to plug in a desired aggregation function. I think that for Edge, we need to allow the aggregation function to be specified in an API object. haven't quite got that far. But anyway, let me show you about what I have got in a revised proposal in its current state. So the idea is to point to a summarizer, which is an API object that describes how to produce these summaries that are more inspired by SQL statements. So it basically has the usual object and type metadata, and then a list of groupers. Each grouper here is basically like an SQL statement with a group by, and then the aggregators that describe the things which you put in the select expressions, what to aggregate and how. So the group by is a bunch of named expressions, because everything in SQL columns have names. But the idea here, oh, that should have been expression. Yeah, wow. Okay. So the this says what to so expression basically how to extract a value from an object. And the approach I'm currently taking is and I'm basically copying what I did in the first proposal, which is two ways of doing that. One is with a JSON path expression. For those of you who are not familiar with JSON path, look it up. It's a fairly common way of just extracting data from JSON. All these CRDs are represented in JSON, so it's a natural fit there. I also put in this kind of switch feature, which I think it just simply inherited from the first proposal. So the idea of a switch feature is it's basically like a case statement. So it's basically each arm of the case statement is like a selector. We can do a label selector, annotation selector, and a field selector. And then the right-hand side of it is just a name. So it's basically categorizing objects into categories. So the idea here is this is like you can say, okay, this object is failed or successful, or it's in one of three phases, or however you want to categorize it. So that kind of feature can let you categorize thing and then count the number of objects in each category. So that's the current state of this proposal. But by naming an expression, I'm really pointing at the idea that maybe we want to go farther and allow more complicated expressions. I think the incumbent here is the Common Expression Language, known by the acronym CEL, pronounced CEL, that already has some presence in Kubernetes. I asked about that in this API Machinery SIG meeting this week. And if you look in the notes there, there's a couple of places where CEL is currently used. The proponents of using it are interested. They think there's more potential uses in Kubernetes. I think so too. I think they could get in our way potentially, as I called out in the meeting. So, for example, if we talk about wanting to replace parts of the API server, more of the API server with SQL database, uses of SQL databases, maybe this gets us in the business of mapping cell expressions into SQL, which may or may not be a problem. More precisely, SQL where clauses. So it would be a non-trivial mapping. But anyway, and then the other question here I'm currently is in the first proposal, every feature value is a string. But if we're anticipating, even in JSON, everything is in a string. It's easily convertible to a string. There's a standard conversion to a string. But in particular, if we're anticipating maybe going to cell, maybe we want to talk about more general values than strings. So it's just starting to look at the stuff that's been defined for cell and see how they're representing general values. And then one other idea that Constantine had, or one of the things that's, and you'll notice also even in the first proposal, that a summary really has two things. And let me try and call it up here. Right, so a summary has two things. It's got this histogram here represented by this slice of status count, and it's got a list of broken objects, references to broken objects. And so the idea here is we recognize that in general, you can't copy the full object every full object from the edge to the center, or even a lower status, because it may be too big. It might not, but it may be too big. Definitely in some cases it's too big. You don't want to even try to copy it all to the center. But if you've got broken objects, how do you find them? Right? If you only have a count, you're kind of stuck. So the thought is, well, if you've got some broken objects, there's either a few of them or there's many of them because there's something going wrong over and over again. There's a pattern. So if you can get a few instances, that'll help you debug the pattern. So the idea is that a summary holds a list of references to broken objects, but the list is limited in length. So it'll only be up to 20 objects long, but that's enough to get you started debugging. If you look at these 20 objects, even if you have to go use other tools, to go remotely to look at them, you know where to look, you can find them, see what's going wrong. Now you can fix the pattern, and the number of broken objects will go way down. So that idea I've copied in the second proposal as well. But the struggle that I'm having is when you refer to a broken object, now in the KCP world, or even in general, right, we don't believe everything's going to be in one kube cluster. So the standard way of referring to an object, it's implicitly scoped by one kube cluster, or in KCP, one workspace. Well, in KCP, they have the idea that things are in workspaces. But they're, with sharding, they're workspaces in servers. So the thing I'm struggling with is, how do you refer to an object that's not in the same server? So I've been talking a lot. I should shut up, and that's about what I've had to say so far.
Mike, I have a question. By broken object here, do you mean that this is, for example, the status of, I don't know, some workload, for example, that indicates that there is a failure in that particular cluster for that object?
Oh, that's another good point, and that's another thing I'm working on revising. So yeah, so there is, in fact, there's in Edge, and I presume also in transparent multi-cluster, there's another layer of status. In normal Kubernetes, right, an object has a status section produced by the controller, generally produced by the controller that animates that type of object. But we've got a layer of management above that, right, that's creating these objects, and it's got its own status for these objects. So in my first proposal, I had kind of a fairly fixed concept of what the status from the management layer looks like. I'm thinking of actually writing that out. So in the first proposal, I had a proposed syntax in a string for the status from the management layer, and that's on which broker would be judged. In my revised proposal, I'm thinking of, first off, kind of writing down a data structure for the status from the management layer, and then letting the same technology for extracting and classifying be able to look at that data structure as well as the regular parts of the object in order to decide in a programmable way which objects should be considered broken.
Okay. Yeah, I was a little confused by the term broken, because I thought initially that there was maybe a corrupted object or something like that. But what I think you mean is that there is some failure status, some kind of failure in the status for that object.
Well, what I'm trying to say is, I think what we should have is let the user program the definition of broken. So again, this is about controlling the information that flows from edge back to center. So we want to let the user program it through API objects.
Okay, yeah, because the thing that comes to my mind immediately is things like broken reference or stuff like that, right?
Right.
So
and I didn't want to have and I think, as I said, it should be programmable, able to take any number of things into consideration.
The other question I have, when you talk about, it seems like to talk a lot about SQL kind of concept for, aggregation, function, and stuff like that, joins, and so on. So is that somehow posing some requirement on the implementation that we want to have underneath?
No, I'm looking at this as, I want to define an interface that poses as little requirement, right? That gives as much freedom as is reasonable to the implementers, and that's actually one of my concerns here. So, I kind of touched on the fact that in for KCP Core, they're working on sharding. I don't fully understand the work. I'm not quite sure how to reflect it. And I'm also not sure how much we want to build in a dependency on that particular way of dealing with multiple API services versus other ways of dealing with it.
Okay. But I don't think you are excluding that one implementation could be to somehow store this, for example, status objects into some kind of SQL database and then use on that those kind of SQL functions.
Right. Yeah. I'm looking at SQL for two reasons. One is simply it's familiar, something that a lot of people know about, and it's been worked on a lot. So, it's already benefited from a lot of design experience, and it's got a lot of mind share. So that's one thing. And the other is, yeah, we might have some level of implementation that maps to it. So that should be easy as well.
Right. I was thinking about this kind of hybrid approach. Maybe this is more about implementation kind of details, so we don't need to talk about that. But I saw that in some community project like cargo workflows, for example, there's this notion of somehow, based on the size of resource, to somehow offload, give the option if you want to offload to some kind of external data store instead of storing in etcd. So I wonder these are kind of approaches we may think about here when we have to deal with these very large status files. And in case we don't have yet a good storage support, like the work on CRDB, for example, and we still have to rely on etcd, we may have to consider maybe this kind of hybrid solution for offloading storage somewhere else, right?
Yes.
Okay, thank you.
So Mike, just to pull us along here, so I heard the word proposal. Are you planning on writing anything up about this so that you can share it with the community, either in the form of RFC or otherwise?
Absolutely. Yes.
Okay. All right, great. That'd be great so that we can pull people along and even have some other contributions. Okay, any other comments or questions for Mike? Okay. Thank you. All right, next up, Constantine, would you like to introduce the RFC that you're working with, the team, and see if we can generate some interest?
Sure. Okay, so this is work that we have been doing with in our team, and with Mike Spreitzer, with Ting Dai, and with Hamid Adebayo. So the purpose of this document is not as much to show an already designed document that we're ready to implement, but rather expose some ideas that we're thinking about, some features that we'd like to have, and get some community feedback on whether these are, useful features or maybe some tweaks to the functionality that we're proposing. And then we have, in the second part of this document, we have a couple of very high-level design ideas as to how we would be able to implement this. So actually, I took, as a matter of fact, this RFC. I copied it from the Istio working group. I had in the past interacted with them, and basically before implementing any feature, they require this type of RFC document, and then they review it during their meeting, and they comment on the features that are being proposed, and I try to follow the same flow here. So in the objective, so we are looking at a way to scale, to realize a scalable propagation of the specification of the status in a system, in a KCP-like system. So we want to build a system that's capable of propagating desired states from a central location to many Kubernetes clusters running at the edge. And then we want to be able to gather and summarize the reported states from the edge clusters. And we want to be able to have the clients define these desired states from a central location, and then like in KCP, they're able to define a policy or a workflow and disseminate that workflow or policy or whatever other resources to several managed clusters. And then we want also to be able to retrieve the reported state. So once we trigger an operation, start running something on a multitude of managed clusters, we want to be able to get back the state from a central location and have an overall idea of what's going on without, having to go inside each managed cluster. So then we want this solution to be scalable, because in the case of edge, we can have a very large number of edge clusters. So we also want it to be basically able to support an open set of API object types, and to be able to propagate these types in both directions, from the centralized control location to the managed clusters, and then also be able to aggregate the actual state and send it from the managed cluster to the centralized location. So in a background, we have a little bit of a kind of historical motivation as to how we started thinking about this. In particular, Paolo, I think he was working on a solution to distribute and retrieve the state of policies in Rackham. There was actually a competing solution that was developed for doing the same thing, distributing and retrieving the state of workload. And we would like actually in this work to ideally propose a solution that works in both cases, for both policies and workload, and have a uniform way of distributing the desired state and then retrieving and summarizing the actual state. We also have, as a background, as a reference, different other CNCF projects that are used in edge computing, and a brief discussion about each of them. I'll not get into that for the sake of being in time here. So basically, we try to summarize this objective as a series of use cases And the use cases have been always written from a perspective of an administrator of an application that's deployed across several edge destinations. And as such an admin, I want to be able to define the desired state for all the API objects that belong to my application from a centralized location. Ideally, I like also to be able to prescribe some rule-based customization of the desired state for each location. And also, in my desired state, I'd like, if possible, to say whether a particular value of an attribute is something that is a must-have, is absolutely it must be that way. Like I do want to have, let's say, I don't know, SSL configured or something, or it's a relaxed requirement where I like to have it, but it's not necessary to. And then basically, I want, of course, to be able to propagate this desired state to multiple destinations. So this is for the desired state. Then for the other part of the communication pattern, I like to be able to summarize this reported state and be able to have a high-level view from the control location as to what's happening in my multitude of managed clusters. And in order to do that, I want to have a programmable combination function that will allow me to summarize in different ways the reported state. I want to basically indicate what API objects, for which API objects I want to have this reported state propagated and summarized to the center. And I want basically overall then have the reported state of the API objects that belong to my application gathered and summarized to a central location. So in summary, basically, the propagation of the desired and of the reported states, we want to have 4 features: customization, relaxed requirements, returning associated objects, and programmable aggregation.
Can I say those 4 features are the things that may be a little bit surprising and differ, for example, from the way some systems handle these things. So, for example, oh no, just stop there. No, I guess I'll say, right? So, for example, by including the relaxed requirements and being able to return information about associated objects, that, for example, is what's in Rackham policy, but not Rackham workload. So by including that, we can do both the policy and workload part.
All right. So for the design ideas, I think we have 2 high-level ideas that basically we like to view them as building blocks. So if we want to implement a system with a functionality and capabilities that we have listed above, we need to have 2 things at least. One building block is be able to define some kind of a communication hierarchy, because we think that a single API service might not be able to efficiently interact with a very large number of managed clusters or workspaces. And the second thing, we want also to have a programmable, basically, aggregation and summarization function. So if we have this communication hierarchy, in figure 2, we're kind of trying to show here that if we define such a communication hierarchy, basically we are able to first deploy the the resources that we want along this hierarchy, and also we can retrieve then the state and partially aggregate this state. A given a given node in this hierarchy can aggregate the state that is receiving from its children, so that we can distribute a little bit the load, relieve the root API service from some of the processing burden, and also this hierarchy can be defined in a distributed way, which would give us some fault tolerance and capability to rebuild it following node failures or nodes being taken out of service or whatever. We could use like a peer-to-peer system or a configuration system or some kind of a mixed approach of both, using some configuration and peer-to-peer. So basically, these are the things that we're thinking might be useful to implement this objective, this system that we want, that scalably propagates both the specification and the status for different resources. We would probably think about adding some functionality to the syncer, because currently the syncer basically is designed that in such a way that it receives information, but it does not have any capability to process and integrate itself in a hierarchy, or run some very simple peer-to-peer protocol that would allow it to also interact with its hierarchy neighbors. Also, one more thing here is that to kind of simplify the design and eliminate this privacy concerns, we are thinking that at least in the first version of this design and implementation, we'd assume that all the participants in this communication hierarchy, basically, they belong to the same organization. Regarding the summarization of the edge information, this relates actually to there are different ways to do this. Mike has just presented before us a way to aggregate and summarize this edge information.
Well, I talked about a way to specify the desired aggregation.
Right.
The implementation is as another matter.
Right. Yeah, and mostly, this is one way. There is also a Google document that shows another summarization methodology. So basically, these were some some ideas that we're thinking would be useful to implement our objective to scalably propagate desired and actual states.
Constantine, Paulo has a question for you.
Yeah.
It's more like a comment, I think, on the aggregation. I see that David is here. I know that he has done some work also with the Syncer views as some kind of framework I think he has for these coordination controllers that allow to sort of process kind of aggregation, summarization kind of thing, right? David, you have done some work in that space. You have already some code doing that.
Yes, we have some code to do that, especially on what we call the Syncer virtual workspace. So, well, in the new terminology, we would call that virtual view, Syncer virtual view. But at least this is, this intermediate component that presents to the Syncer only what it needs and possibly transform the information, the resources, when exposing them to the Syncer, and the other way around, when the Syncer updates the status, this transformer, this virtual workspace, mainly transforms the status accordingly and then updates the status of the main KCP resource accordingly. So it seems that there is some sort of convergence, yes, in the need. On the other hand, the overall use case that drove the current implementation is not the same, because it's explicitly with not many sync targets, but having everything stored locally, so through labels or annotations mainly. So yeah, on one hand it seems to be quite the same need, but on the other hand that's not clear to me how much could be shared in terms of components, at least runtime. Obviously, in terms of sharing code, we could probably, think about structuring things to share as much code as possible, both in the Syncer and possibly in, components like proxy components like the virtual workspace. But then, maybe that would be the main place where things would be shared, because after thinking about it, it seems that the use cases are very different in what they require. Does it make sense?
Yeah, I think it makes sense, and actually, I will definitely add a reference to your work in this document. Yes, and I think we should, yes, we should link it.
Yeah, and by the way, I think what could be maybe a reference or interesting is the virtual workspace concept. The fact that we have in KCP this concept where you can, have a sort of proxy before KCP itself, before the shard, that, prepares, transform, changes information, gathers it to present it to an external component for a dedicated use case. So obviously, you might be able to have such a virtual workspace that would not be the same implementation as the one for the Syncer, because obviously you would be reading objects outside and all these policies that you're mentioning previously. But the overall structure of having on one side, between KCP and the Syncer, which is an external agent, having this sort of virtual workspace that prepares the information, I assume that would be probably a direction that could be useful for you as well.
And David, if I understand correctly, there are already different type of virtual workspace, right? I understand there is one for AppSync, for example. There is one for Syncer.
Exactly. Yes. Well, and even there are more virtual workspaces, because even for API exports, in fact, the URL that you have in API exports, they are driven by, they are provided by a virtual workspace as well. What could be shared for probably between EMC and TMC is some parts of the implementation of the Syncer virtual workspace. We already do that for upsyncing and syncing, for example. We have a common part other part that, is related to what are the APIs that we are going to expose. So look into the scene target, get the various APIs that are supported and compatible, for example, and then expose them. All this aspect could be possibly maybe the same. And then on the other hand, all the aspect of how we transform the information and how we summarize the status, obviously it would be a bit different. So probably we can, segment the code so that the things that can be shared would be shared.
Yes, I was thinking similarly. I will admit to one difficulty that I haven't found a reason or need yet to articulate very clearly, but it is bothering me. One of the things we learned from Verizon about their customization is that, let's see. Oh, actually, no, this is good. Yeah, I think they said they don't want to have all the inputs to the customization at the edge, but that's okay for us because with the inputs at the center, we can do the customization in the center and present the customized view to the edge. So yeah, strike that. I think we're good.
Konstantin, I have also another question. I don't think was clear, at least to me, in the use cases. If you can show 1 second that use case section. If that use case that you have, I think they're talking about state that you want to aggregate and summarize. I wonder if somehow you cover also scenarios like, for example, Kyverno that is actually creating this policy report in the local cluster. And then actually what you have to do is to bring back that report. So it's a whole new object. It's not just the status of an existing resource that is somehow what today happens when you use the sinker or even this sinker view, workspace view summarization that David was talking about, right? It's really actually about upsyncing new resources and summarizing them, aggregating them, and so on. I don't know. I don't see explicitly covered that scenario here. I wonder that.
No, it is. We did write it down here. The speaking to it was not particularly clear, but and in fact, the penultimate bullet here under requirements, actually types is not exactly on point because it might be more fine-grained than whole types, but the point is exactly what you're talking about, is we may need to get information back from objects that are associated with the objects that went from center to edge, right? So for example, right, the example they keep talking about in transparent multi-cluster is suppose you propagate a Kubernetes deployment object from center to edge, and you want to get back information from the associated pods.
Yeah, okay.
Right, or a policy, right, in things like Kyverno or anything else that has policy report objects that are separate from the policy, requirement objects, similar kind of thing.
Right, but you are propagating back the whole object. It's not just the status of
Well,
that associated object.
well, so my point here in general, again, I think it wasn't quite clearly said when Konstantin was talking, but the thinking is, you may not be able to afford always to propagate the whole object back. I think the right way to think about it is you're always going to want some kind of summary. You may want the whole objects, or you may have to satisfy yourself with something much less.
Okay.
Right, because we've seen use cases where the volume of status data at the edge is just way too big to consider bringing it to the center. And that's one of the reasons we have a hierarchy. We may want a hierarchy is so you can do some reducing or processing along the way in. So, for example, your exception handling, typically, hopefully, will be mostly automated, and that automation may live in the intermediate vertices in the hierarchy. So even your error handling, your response, won't necessarily all be in the center. It can be as you move along the hierarchy.
Okay, thank you.
Really like the work that's coming along here. Thank you, Konstantin, for presenting. Any other questions or comments for Konstantin? So I've gone ahead and taken the liberty to share this with the KCP Dev Google group. So now that it's out in the open in the community, others can make comments. I invite you all as members to take a closer look at the document. This is largely resonating as I think as our main thrust. It's behind Edge MC or one of them. And so any and all information that you can impart on this will help us form and shape the challenge ahead. All right, thank you everybody for attending. Mike, I've taken number 5 that was listed on the agenda and pushed it to January 26th, the next community meeting. Thank you all for attending today, and I look forward to seeing you all again out there.
Thank you.